So we'll be running a ordinal encoder here, and after running an ordinal encoder, we'll be just having our encoded output. So if we see the head of our training, it will be different. See, now it has all converted into numbers. Okay, so now it's good for to feed into a model. Now we have not any objects or strings or whatever. We only have numbers. So numbers are easily trainable up to this model. Now we have X test also at the same way encoded. Now we have came to the part where we can train our random forest classifier model. Okay, so firstly we'll try to train it with the default parameters, and next we'll be changing some of the parameters. So let me say what these are changes. Let's say first time we take 10 decision trees for creating our model. Next time let's say we take 100 decision trees for our model. So after that we'll compare that what is the change in the performance. What is the change in the performance? Or even is there a change in the performance, it has become good or bad, we don't know. For that we'll be running a model with the default parameters. So we'll be running our model with the default parameters. So default parameters like n equals to 10. N equals to 10 means there are 10 decision trees. So let's try and see how we are doing this. We are just firstly importing the random forest classifier from the sklearn. We are creating a random forest instance of random forest classifier, and just then running the rfc.fit, and we are making prediction and seeing that what is the model accuracy. So if we run this, the model accuracy here is 0.9247, means 92.47%. okay, and also we have built it with the default parameters. So the number of estimators here is 10, means there are 10 decision trees to build the model. Now let's see and check how it is different with the n estimators equals to 100. That means what difference it will cause if we use 100 decision trees. So let's run this. We'll be doing almost the same step. We'll be declaring another instance of random forest classifier with n estimators equals to 100. We'll be running a fit. We'll be predicting, and let's see what is the accuracy here. And here, okay, it's a pretty good accuracy. Last time it was 92%, and here we have 94%. So it has a 2% increase in the model output. So we can say this has increased. So it means that increasing the number of trees increases the performance of the model. This is the one conclusion we can draw with this kind of thing. Okay, now next what we'll be doing, we have to figure out which all features are important and which all features are correlated, or which all features are not significant for the model. So we have run this classifier. Now these are all the default parameter it has. Now let us see the feature importance of the model. There is a function called feature importance in the classifier in the random forest, and it will tell you about the feature importance and the feature score of each and every column, that whether this feature, let's say there is a doors feature, it is important for the like good car or not, whether the number of people sitting is important features or not, luxury is important for the people or not. So these all kind of things will be done with the help of feature importance. So let me run this, and if we run this, we have output that safety is most important parameter above all, that people are preferring the safer cars. Then the number of, like, basically the capacity of the car, and at the last we have doors, because people are not worried about the number of doors. So we can say that door is not playing that importance in the model selection, model building, and safety is important, a very important and crucial rule in the model building. So that means we can discard doors somehow to reduce the data set size and make our training more efficient. So let's see and try to visualize that what is happening here. So we are here, you are using bar plot from the SNS, and let's see that how our feature importance visualization looks like. So if I try to run this, that we can see that safety is playing a very good important role. Okay, and doors are not playing that important role, so we can try to build features based on this all above features. Like this above features we'll be using in building a new model, and we'll be discarding this doors feature, and let's see that how it impacts the performance. Okay, so let's see how it improves the performance. Okay, so let's drop this door for now. Okay, and make another model. So we are doing df.drop class and doors because we don't want our class to be an input feature, and we also don't want doors to be our input feature. Okay, now we are again doing train test split. So we go for train test split. Now we'll be again encoding the data. We'll be creating a model with 100 estimator, and see here the accuracy has changed 92.64%, and above without that it was having 92.47%. so not a much hike, but it has showed some or more accuracy improvement. So this is how the feature selection can be done. We have selected a feature which is important. There's a way we are doing with the feature importance. There is another feature which is least important. If you go to this diagram, this is like a lug boot. So if you try to remove this, you may see some other accuracy. Your model may perform well or even worst in the case. So you have to try and test that up to which extent you want to remove your features for the model performance. Now next thing, here comes the confusion matrix. This is I have already explained, and you might be also familiar with if you are coming with the backgrounds like logistic regression and all. So you have done classification, simple binary classifications, so you might be familiar with that what this confusion matrix is. But for the sake of understanding, we'll just run a simple example and try to learn confusion matrix. So confusion matrix looks like this for the binary classification. So let's say we have an input feature, we have a classification problem, let's say spam or ham. Okay, so there are two scenarios. What is the actual output and what is the predicted output? So let's say this is spam, this represents spam, this represents ham, and for the predicted, this row represents spam and this row represents ham. So for spam we have this row representing, for ham we have this column representing basically, and for the predictions we have this row, and for the ham we have this row. So let me erase this part only so that we can go and see. So what does this confusion matrix satisfy? That if the model is predicting spam and it is actually spam, then it is true, there is no problem. And if the model is predicting it is ham, means not spam, and also the actual output is not ham, okay, so this is a true output, that it was no and it was predicted also no, and it was yes and it was predicted also yes, so this is true. So what here is the thing with confusion matrix, everything comes into a diagonal is a true output or accurate output. Apart from that, if the output is ham, your model predicted spam, or the output is spam and your model predicted ham, then it will be a erroneous result. So this is the confusion matrix all about. So let's see how it's working. It has also some terminologies like true positive, true negative, false positive, false negative. So true positive is that when a certain class is actually belong to the class, but and also it is predicted true, means like true predicted true is called true positive, and this is all how the definitions work. True negative means like predicted observation does not belongs to class, and actually it is also not belonging to that class. For example, you have ham as output and actually that thing is also ham. So this is how the confusion matrix works. So we are importing confusion matrix from sklearn. Okay, we are creating and printing the confusion matrix. So this is how the confusion matrix look. This is a 4x4. Mind it, this is a 4x4 confusion matrix. So why 4x4? There the question comes to your mind, because we have 4 features in output. So these columns will be representing the actual output, and these things will be, this side of the part will be representing the predicted output. So we need 4 to represent the actual and 4 to represent the prediction. as in the case of 2 cross matrix, because we had two outputs. For 2 this side yes or no, and here also yes or no. So this is how the side of the confusion matrix is defined. Okay, I think this is pretty much done for the confusion matrix. Last steps we are doing to generate a classification report. This is a very simple command to run classification report. We have to import it from sklearn and just run. And there is all you think you can precision, recall, F1 score. These are terminologies you must be familiar with. What is precision? What is recall? Okay. Now and what we have concluded that on increasing the number of trees, the performance is increased. On selecting the features and removing the not used features, the performance is also increasing. Okay, we can visualize and see with the help of confusion matrix and all sort of things. So this is the conclusion of this video. Okay, the last thing and the closing notes about this, that there are some links you can find where you can learn. There is Wikipedia, you can learn random forest if you want to get all more intuition. There is a sklearn library, obviously. It is a very good library, you can say, and it is most widely used. It has all pre-implemented machine learning algorithms and all. So what you can do there, you can just go and type and search random forest, and you'll get implementation of random forest. You will get a dummy data set. You can take it and upload it in Kaggle. Here you can see, you can upload your own data, you can create a model, evaluate performance, and you can kill it. So this is how you'll work. And this is all for the random forest. You can also learn the random forest regressor in the same way. You can go and search in the Kaggle. This Kaggle is very good platform to learn all these things. I'll be sharing this notebook with you attached with this video. You can try and run it on your own. So best of luck till the next time. I think this had made you the pretty much clear about the random forest classifier. There are some blogs also available for the random forest and towards data science and this Medium. You can also go through them. And yeah, best of luck. Thank you.